Hi, welcome back to the next video in our distance learning series for pre-calculus. We're going to go into a little bit more with vectors. So we started vectors last week and talked about just kind of basically what a vector is, finding magnitude and direction and some of those basic operations. We're going to go a little bit further and talk about some more things we can do with vectors. As always, a good idea to have a piece of paper and something to write with so we can follow along here. Pretty straightforward stuff, honestly. The first couple of things you see on the list here, the unit vectors and a little bit more notation, super straightforward. The dot product and then the angle between vectors, a little tiny bit of more work, but not by a whole lot. So I'm going to try to get through this pretty quickly to kind of honor your time. So let's go and get started here with a review of last week. But before we do that, let's kind of lighten the mood a little bit. And I found a good little meme with our old friend Vector from Despicable Me. And I do wonder if this is kind of what you guys are going through during this whole distance learning thing. So I wonder if you can relate to that. So anyway, hope we got a good little laugh about that as we get started here. So let's get into what we did last week real fast. So we know component form is with those little pointy brackets. That means it starts at the origin and goes to the point xy. Remember, if you're given 2 points of a vector, we find that component form by doing end minus start. I'm not going to have to worry about that today. I'm just going to give you the component form right off the bat. Remember magnitude, doing that notation with the double bars, which is Pythagorean theorem. Direction angle, remember we found the direction angle by doing the inverse tangent. Of course, we got to be mindful of what quadrant we were in. And let's do a quick example from last week. I'm not going to spend much time on this, but I just want to kind of get us back into what we're doing. So let's say vector A, start point, end point that you see there. Let's find component form, magnitude, and direction. So component form, remember end minus start. We got -1 minus -5, and then 6 minus -1. Watch those signs, and that's going to become 4, 7. The magnitude of that will be the square root of 4 squared plus 7 squared, which would be equal to root 65. Okay, to leave it like that. And then the direction angle theta, we're going to do the inverse tangent of 7/4. And again, pop that in the calculator, make sure you're in degrees, whatever you're using, 60.26 degrees. And because it's in quadrant 1, that's all we got to be able to do. Okay. Now I am going to be using this vector A of 4, 7. I'm going to be using that a few times throughout the whole video. So just kind of be mindful that I'll be using that same one. Okay. So let's get into what is a unit vector. Well, a unit vector is a vector in the same direction as whatever vector you're given. It just has a magnitude of 1. Okay. You might be saying, well, why would you need that? Well, it is useful in some physics applications like work. If you're dragging something up the hill and want to calculate the work. So it's needed in that. We're not going to get into those applications this year in pre-cal, but that's kind of why we use unit vectors. So all you do to find a unit vector is once you have component form, you just divide both components, the x and the y, by the magnitude. Okay? So symbolically, it would look like this. So if you have x, y, the unit vector is going to be x divided by the magnitude, comma y divided by the magnitude. That's it. Okay. So with our vector we just had of 4, 7, let's write the unit vector. Well, we just found the magnitude, which is root 65. So that means my unit vector is going to be 4 over root 65, comma 7 over root 65. That's it. That's literally all you have to do to find a unit vector. Okay. Let's go and do one more example, and I'll do, let's say vector B that is made up, -3, 9. And let's find that unit vector. Well, again, first thing you do have to do is find the magnitude. So with Pythagorean theorem, -3 squared and 9 squared, that's 981. Add those together, you get root 90. And then you write your unit vector. Whatever the vector starts out with, -3 and 9, divide them both by the magnitude, and that's it. As the saying goes right now, that's it. That's the tweet. So that's all there is to doing unit vectors. Okay? So that's the first thing you got to know for this week is how to write a unit vector. Second thing, and again, going back to physics, we have another notation that I'm going to throw at you. In addition to that component form, it's called IJ notation. The base unit vectors are called I and J, and you can see what they are right there. The I is just that base horizontal vector, and the J is the base vertical vector. So so there's no way we can write a vector using IJ notation instead of component form. And it's like this. So if you're given any vector xy, we can write it as xi plus yj, okay? And again, you might be saying, why do we need to know this? If you go into physics, especially college level physics, a lot of times they express vectors in this ij notation. So it's something to be exposed to, okay? So again, our old vector 4, 7, what would that be in ij notation? 4i plus 7j. That's all you have to do, okay? The signs come along. So we have our vector b, negative 3, 9. You're going to write that in ij. Well, same thing, negative 3i plus 9j, okay? And I'll make up one more. So if we have c of 5, negative 6, then c would be 5i minus 6j, okay? Whatever the sign is, it just goes in front of that number, and then you attach the ij to it, okay? So if you're asked to write a vector in IJ notation, that's all there is to it. Again, that's it. Okay, don't overthink this. Okay, so we got two more things to talk about. So the next one is another operation. It's called the dot product. But let's talk about the operations from last week just real fast. Remember, last week we talked about how to add, subtract, and do what's called scalar multiplication. So let's use our a and b that we've been using for the whole video so far, and let's do 3a minus 2b real fast. So we want 3a minus 2b, we got 3 times a minus 2 times b, distribute those through there, that becomes 12 to 21, plus, notice I'm distributing the negative sign also, so that becomes 6 negative 18 for the second vector. And now we just add the x's, add the y's, watch your sign, so it becomes 18 comma 3. Now that's it, right? That's what we did last week. Now we have this thing called the dot product. Okay, now the important thing to remember about the dot product is the answer is going to be a normal number. The answer is not going to be a vector. Okay, to find the dot product, we're just going to multiply the x values, multiply the y values, and then add those guys together. Okay, that's all you have to do. So using my same vectors a and b, by the way, that's kind of what it looks like symbolically, but it's easier to kind of say that kind of verbally what it is. Let's use our AB up here. So let's find A dot B. So that's going to be 4, 7 dot negative 3, 9. And again, multiply the x's. So 4 times negative 3. And then multiply the y's. 7 times 9. So you got negative 12 plus 63. Add them together. 51. Boom. Dot product. Done. Okay. Now, as you're doing dot products, as you do a couple of these and do the next couple of examples, it is important to keep in mind they can be positive or negative, or they could even be 0. Okay. The special case is if you do have a dot product that comes out to be exactly 0, that means the vectors are perpendicular. You might remember that word from geometry. That means the vectors are at 90-degree angles to each other. Okay. So let's do a couple more examples. And again, I encourage you to pause the video here just to see if you can find the dot product on your own. So here's V and W, just made those up. So let's find V dot W. So again, we're going to multiply the x's, multiply the y's. So we've got negative 2 times negative 4. And then we got negative 7 times 3. So we got positive 8 and negative 21. Add those together to get negative 13. And again, it's okay. It's just a number. That's okay to be negative. Second example, again, pause the video, see if you can find the dot product on this by yourself. And we'll go back together in just a couple seconds. So in this case, we have m dot n. So we have 5 times 4 and then negative 5 times 4, which ends up being 20 minus 20, which there's our special case. And remember, if you get 0, that just means those two vectors are perpendicular. Let's do one more example. And again, if you want to pause the video and do this on your own real fast. Always multiply the x's, multiply the y's. In this case, the y's come out to be 0. So it just comes out to be 36. Okay. Now, the reason we talked about dot product, really, again, there's some other physics applications that we do with dot products, but there's one application that we are going to do, and that would be to be able to find the angle between two vectors. Okay, so for any angle between two vectors, whether it's, whatever the two vectors are called, this is your formula. It's the cos inverse, don't forget the -1, of the whole quantity of the dot product on top, and then the two magnitudes on the bottom. Okay, a lot of notation there, but make sure you see what that is. So really what that's saying is the inverse cosine dot product on top and the multiplying of the two magnitudes on the bottom. Okay, calculator's going to do all the work, whether you use Desmos or whatever. Just make sure you're in degrees, but it's going to do all the work for us. Okay, so let's use our same vectors A and B that we've been using. So we already found the magnitudes earlier. So it was root 65 and root 90 for the two magnitudes. And we just found the dot product, A dot B was 51. So now it's just a plug and chug, right? So my theta, we just plug in the dot product on top and the two magnitudes on the bottom. Looks just like that. And again, I'm not doing anything else. I'm letting the calculator do all the work. This is a little copy paste from Desmos I put in. And again, make sure you're in degrees. So your answer is just 48.18 degrees. Done. Okay, so once you find the dot product, once you find the two magnitudes, you just plug it in and go. Okay, last example, and we're going to wrap up the video. So here's two more vectors. So I got vector x and vector y. So let's find the angle between these two guys. Again, we got to find three things. We got to find the dot product and the two magnitudes. So I'm going to start off with the two magnitudes. So magnitude of x, remember the Pythagorean theorem. So that could be root 85. Magnitude of y, Pythagorean theorem, comes out to be root 45. And then we got to find the dot product. So x dot y, again, multiply the x's, multiply the y's. Ends up being a negative number. Negative 12 minus 27 is negative 39. That's okay. We're going to plug that into our formula. So dot product on top, the two magnitudes on the bottom. And make sure when you type it in, especially on the bottom, make sure you keep those two square roots separate. And then your answer there is 129.09 degrees. The one thing to keep in mind as we finish up here is theta, when you're doing the angle between vectors, it's always going to be between 0 and 180. Okay, always. So just kind of keep that in mind. That's it. So just as kind of a recap of what we did today, we know how to find the unit vector. We know how to write IJ notation. We know how to find the dot product, multiply the x's, multiply the y's, add them together. And then we know how to use the dot product to find the angle in between vectors. Okay? And that is going to be the whole kind of length of the assignment. The assignment's going to be a pretty short assignment this week. So that's it. That's the video. Hope you guys found this informative, and hope you're able to follow along pretty well with this. If you have any questions, feel free to email me. Also, of course, feel free to subscribe if you want to be notified when the last few videos of the school year get put up. And feel free to share this with anybody else in pre-cal that's kind of going through the same thing right now. Hope you guys are well, staying healthy, staying inside. I miss you guys. Those of you that are seniors, I look forward to seeing you guys. Definitely the virtual graduation, and hopefully in an in-person graduation soon. And of course, those of you that are juniors, hope to see you. I look forward to seeing you guys when we do return to school next August. Take care of each other, take care of yourselves, and until next time, keep studying.